All right, hey guys, we are going to go over lesson 7.3 today. We're skipping 7.2. I'm going to do that when I am back. So we're skipping to 7.3, which is solving one-step inequalities with multiplying and dividing. You do need your notebook out and a pencil. So if you do not have that, pause the video and get that, please. All right, first thing, in your table of contents, can you go ahead and put a title? So pretend this is your notebook. In your table of contents, put a title, one-step inequalities, and then put whatever page number you're on. Okay, so if you're on page 43, whatever page number you're on, and then it's lesson 7-3. So if you guys can do that to start with, and then when you're ready, push play. All right, so in your notebook, we're going to go ahead and start by doing an example. So I'm just going to kind of split my page here. And we're going to start with solving some inequalities that we didn't quite get to the other day. So let's go ahead and start with this one in your notes. We're going to say 8x, when is that less than or equal to 40? Okay. Like we were doing in class, we're going to draw our line down through the equal sign, and we're going to try to solve this. So I'm going to think, hey, right now it's multiplying by 8. I'm going to do the opposite and divide by 8. All right, if I divide by 8, I'm left with x equals 5. Okay, from here now you guys should know how to do this pretty well. So I'm going to come draw my number line. And let's go ahead and put some numbers on my number line. You guys can just draw one. Maybe I'll put zeros here. Here's 5, 10. Here's -5. Okay, and I'm going to put a dot above the 5. Now you guys know it should be filled in because of this equal sign here. So I'm going to fill it in. And now I'm going to come to a test point. Now remember, you can test any number you want. I'm going to test 10. Okay, so remember, when you test a number, you need to come write it down. So I'm going to test 10. I usually box it. Okay, it's kind of like doing a check. I'm going to do 8 instead of x. I'll put a 10. Is that less than or equal to 40? So I'm going to work that out. 8 times 10 is 80. Is that less than 40? Well, 80 is not less than 40, so I'm going to write no. So 10 does not work, so I am going to go the opposite way than 10. I don't want to go towards the 10. Okay, my last step that I need to do is I am going to write, hey, this shows all numbers, x, that are less than or equal to 5. And there's my final inequality. All right, go ahead and go below that and draw another set so we can do another set in our notes. This one's going to look a little different. We didn't do any of these the other day, so this will be a really good one to check. So what if I have x over 2 is greater than 7? Okay, so now my problem looks a little bit different. I'm actually going to read that differently too. I'm going to say x divided by 2, is that bigger than 7? So first thing, you're going to draw your line down. Okay, now I'm going to think, right now this says divided by 2. So the opposite of dividing by 2 is I can times both sides by 2. Okay, notice how I did times both sides in blue. So over here, the 2's cancel, and I get x equals 14. Okay, so I'm going to come over to the second box, and let's draw a number line. So maybe here's 0, here's 14, maybe here's 28 if I double it, there's -14. So I just like to put a couple different numbers on here. So a dot goes above 14. This time I do not fill it in because there's no line underneath. All right, but now I need to do a test point. So maybe I'm going to test 28 this time. Okay, so I'm going to come up down here and say, hey, I'm going to test the number 28. So I'm going to rewrite the problem. I'm going to write 28 over 2. Is that bigger than 7? So 28 over 2, or 28 divided by 2, is 14. Is 14 bigger than 7? Yes, it is. Okay, so you notice I kind of just wrote the word yes there. So 28 does work. So I want to go towards the 28. So that means all numbers bigger than 14 are going to work in that inequality. So I'm going to say, hey, it's all numbers bigger than 14 work in that inequality. And you just solved a division inequality. All right, let's try another one if you have room for one more set on your page. Okay, so again, I'm just going to kind of set it up. Again, wherever you have space on your page, hopefully you have one more space. If you don't, you can just go to the back of your notebook. So what if I have -6 is bigger than or equal to x over 7? Okay, so here's my next one. So first thing you do is you're going to draw your line down. All right, then I'm going to think, okay, what's the opposite of dividing by 7? I'm going to times by 7. Times by 7. My 7's cancel. I get x equals negative 42. All right, now I'm going to come over and draw a number line. Okay, when I have a negative number, I always put 0. Maybe here's negative 42, here's positive 42. If I went further, maybe I'll be like, oh, here's negative 60 way over here. You could really choose anything, or maybe I'd do 84 there. Whatever you want is fine. All right, so I'm actually going to change it to 84, so I'm actually counting by something. So I'll just change that to negative 84. All right, my dot goes above negative 42. I fill it in because of the equal sign. Okay, I'm going to pick a number to test. This time, I'm going to test 0. All right, so I'm going to write, hey, I'm testing the number 0. So let's write this. I have negative 6. Is that bigger than or equal to 0 divided by 7? So I have negative 6. Is that bigger than 0 divided by 7 is 0? Is negative 6 bigger than 0? It is not. So I write no. So do not go towards the 0. Go the other way. So it would look like that. My final answer is x is less than or equal to negative 42. That is my solution. It's all numbers less than or equal to negative 42. All right, our next one you do not have to put in your notebook. I just want to kind of do this one together. So if you want to do it with me, you can go in the back of your notebook. Otherwise, just watch, and I'm going to be asking you questions as you watch this video. So I'm going to say that you are at the fair, or you're somewhere, and it costs $5 per ride at the fair. And you have $40, so you can spend no more than $40. I want to know, how many rides can you go on? Okay, can you go on just 2 rides? Can you go on 10 rides? Can you go on 20 rides? Could you go on 40 rides? Okay, so think about how many rides could I go on at the fair? All right, so we're going to start by saying, hey, we don't know how many rides we can go on. Let's call that R. I do know it's $5 per ride. So if I went on 1 ride, it'd be $5. 2 rides would be 10. 3 rides would be 15. If I went on R rides, it'd be 5 times however many rides I go on. Okay, here's how much I spend, because it's $5 per ride. Now, there's how much I spend. What I spend has to be less than $40. Could be equal to 40, so it could be less than or equal to 40. So I'm going to write 5R, that's how much I spend, is less than or equal to 40. I just wrote an inequality. Okay, now if I was going to try to solve this, I'd come over here and I would solve it by drawing my line down. I would divide both sides by 5. I get R equals 8. Okay, now that doesn't mean that's my exact answer. I'm going to come over to a number line. So here's 8, maybe here's 0, here's 16. I'm going to put my dot above 8. I know that works already. All right, let's do a test point. So if I test, maybe I'll test, I'm going to test 3 rides. Okay, so if I test 3, I would go 5 times 3. Is that less than 40? Well, 15 is less than 40. So it looks like I can go on less than 8 rides. So I'm going to say I can go on my rides as less than or equal to 8. Now, if I tested a number over 8, I probably wouldn't be able to go on that many rides. Let's test 16. So if I did 5 times 16, is that less than 40? Well, 5 times 16 is actually 80. 80 is not less than 40, so that's a no. So I could not go on 16 rides. So the most I can go on is 8 or less. All right, so your learning goal for today is, if I give you an inequality that involves multiplying or dividing, you can see this is a multiplication one, this is a division one. If I give you one that looks like that, can you solve both of those? And then could you graph them? And could you do your test point? And then could you write your final solution? So remember, if you see a multiplying one, you do the opposite and you divide both sides by 5. Here, if you see a division problem, the opposite of dividing by 3 is you're going to times by 3. So then it cancels. And then that will help you get your your main boundary point number that you need. All right, now the one thing I did not go over is if it was a decimal. So if you had like 1.5x is greater than or equal to 15, you would still do it the same way. It's a timesing problem, so you're going to do the opposite and divide by 1.5 on both sides. And then you can kind of go from there. All right, so then your homework, now that you've watched that video, you're gonna get some time to practice. You're gonna have a 6-problem worksheet you're gonna need to get from your teacher. I did not mean to cross that off, but get that from your teacher, and please show all your work, and we will go over it the next day.